A forge is a type of hearth used for heating metals, or the workplace where said hearth is located. The forge is used by the smith to heat a piece of metal to a temperature where it becomes easier to shape, or to the point where work hardening no longer occurs. The metal is transported to and from the forge using tongs, which are also used to hold the workpiece on the smithy's anvil while the smith works it with a hammer. Finally, the workpiece is transported to the slack tub, which rapidly cools the workpiece in a large body of water. The slack tub also provides water to control the fire in the forge. Types of forges: coal forge. A forge typically uses bituminous coal, industrial coke or charcoal as the fuel to heat metal. The designs of these forges have varied over time, but whether the fuel is coal, coke or charcoal, the basic design has remained the same. A forge of this type is essentially a hearth or fireplace designed to allow a fire to be controlled such that metal introduced to the fire may be brought to a malleable state or to bring about other metallurgical effects. The forge fire in this type of forge is controlled in three ways: amount of air, volume of fuel, and shape of the fuel fire. Over thousands of years of forging, these devices have evolved in one form or another as the essential features of this type of forge: tuer a pipe through which air can be forced into the fire, bellows or blower a means for forcing air into the tuer, hearth a place where the burning fuel can be contained over or against the tuer opening. During operation, fuel is placed in or on the hearth and ignited. A source of moving air, such as a fan or bellows, introduces additional air into the fire through the tuer. With additional air, the fire consumes more fuel and burns hotter. A blacksmith balances the fuel and air in the fire to suit particular kinds of work. Often this involves adjusting and maintaining the shape of the fire. In a typical coal forge, a fire pot will be centered in a flat hearth. The tuer will enter the fire pot at the bottom. In operation, the hot core of the fire will be a ball of burning coke in and above the fire pot. The heart of the fire will be surrounded by a layer of hot but not burning coke. Around the unburned coke will be a transitional layer of coal being transformed into coke by the heat of the fire. Surrounding all is a ring or horseshoe-shaped layer of raw coal, usually kept damp and tightly packed to maintain the shape of the fire's heart and to keep the coal from burning directly so that it cooks into coke first. If a larger fire is necessary, the smith increases the air flowing into the fire as well as feeding and deepening the coke heart. The smith can also adjust the length and width of the fire in such a forge to accommodate different shapes of work. The major variation from the forge and fire just described is a backdraft where there is no fire pot, and the tuer enters the hearth horizontally from the back wall. Coke and charcoal may be burned in the same forges that use coal, but since there is no need to convert the raw fuel at the heart of the fire is handled differently. Individual smiths and specialized applications have fostered development of a variety of forges of this type, from the coal forge described above, to simpler constructions amounting to a hole in the ground with a pipe leading into it. Gas forge: a gas forge typically uses propane or natural gas as the fuel. One common, efficient design uses a cylindrical forge chamber and a burner tube mounted at a right angle to the body. The chamber is typically lined with refractory materials such as a hard castable refractory ceramic or a soft ceramic thermal blanket. The burner mixes fuel and air which are ignited at the tip, which protrudes a short way into the chamber lining. The air pressure, and therefore heat, can be increased with a mechanical blower or by taking advantage of the Venturi effect. Gas forges vary in size and construction, from large forges using a big burner with a blower or several atmospheric burners to forges built out of a coffee can utilizing a cheap, simple propane torch. A small forge can even be carved out of a single soft fire brick. The primary advantage of a gas forge is ease of use, particularly for a novice. A gas forge is simple to operate compared to coal forges, and the fire produced is clean and consistent. They are less versatile, as the fire cannot be reshaped to accommodate large or unusually shaped pieces. It is also difficult to heat a small section of a piece. A common misconception is that gas forges cannot produce enough heat to enable forge welding, but a well-designed gas forge is hot enough for any task. Finery forge. A finery forge is a water-powered mill where pig iron is refined into wrought iron. forging equipment. Anvil. The anvil serves as a workbench to the blacksmith, where the metal to be forged is placed. Anvils are made of cast or wrought iron with a tool steel face welded on or of a single piece of cast or forged tool steel. The flat top has two holes. The square hole is called the hardy hole, where the square shank of the hardy fits. The smaller hole is called the punch hole, used as a bolster when punching holes in hot metal. Hammer. There are two types of hammer used in the workshop. Hand hammer. It is used by smith himself. Ball peen hammer, cross peen hammer, straight peen hammer, sledgehammer. It is used by striker. Chisel. Chisels are made of high carbon steel. They are hardened and tempered at the cutting edge while the head is left soft so it will not crack when hammered. Chisels are of two types, hot and cold chisels. The cold chisel is used for cutting cold metals while the hot chisel is for hot metals. Usually hot chisels are thinner and therefore cannot be substituted with cold chisels. Tongs. Tongs are used by the blacksmith for holding hot metal securely. The mouths are custom-made by the smith in various shapes to suit the gripping of various shapes of metal. There are various types of tongs available in market: flat tong, rivet or ring tong, straight lip, fluted tong, odd tong, fuller. Fullers are forming tools of different shapes used in making grooves or hollows. They are often used in pairs. The bottom fuller has a square shank which fits into the hardy hole in the anvil while the top fuller has a handle. The work is placed on the bottom fuller and the top is placed on the work and struck with a hammer. The top fuller is also used for finishing round corners and for stretching or spreading metal. Hardy. The hardy is a cutting tool similar to the chisel. It is used as a chisel or hammer for cutting both hot and cold metals. It has a square shank that fits into the hardy hole in the anvil, with the cutting edge facing upwards. The metal to be cut is placed on the cutting edge and struck with a hammer. They are also used with set tools which are placed over the workpiece and struck. Slack tub. A slack tub is usually a large container full of water, brine, or oil used by a blacksmith to quench hot metal. The term is believed to derive from the word slake, as in slaking the heat. Types of forging. Drop forging. Drop forging is a process used to shape metal into complex shapes by dropping a heavy hammer with a die on its face onto the workpiece. Process. The workpiece is placed in the forge. Then the impact of a hammer causes the heated material, which is very malleable, to conform to the shape of the die and die cavities. Typically only one die is needed to completely form the part. The extra space between the die faces is called the flash. It acts as a relief valve for the extreme pressure produced by the closing of the die halves but is eventually trimmed off of the finished part. Equipment. The equipment used in the drop forming process is commonly known as a power or drop hammer. These may be powered by air, hydraulics, or mechanics. Depending on how the machine is powered, the mass of the ram, and the drop height, the striking force can be anywhere from 11,000 pounds to 425,000 pounds. The tools that are used, dies and punches, come in many different shapes and sizes, as well as materials. Examples of these shapes are flat and V-shaped, which are used for open die forging, and single or multiple impression dies used for closed die forging. The designs for the dies have many aspects to them that must be considered. They all must be properly aligned, they must be designed so the metal and the flash will flow properly and fill all the grooves, and special considerations must be made for supporting webs and ribs and the parting line location. The materials must also be selected carefully. Some factors that go into the material selection are cost, their ability to harden, their ability to withstand high pressures, hot abrasion, heat cracking, and other such things. The most common materials used for the tools are carbon steel and, in some cases, nickel-based alloys. Workpiece materials. The materials that are used most commonly in drop forging are aluminum, copper, nickel, mild steel, stainless steel, and magnesium. Mild steel is the best choice, and magnesium generally performs poorly as a drop forging material. Gallery, photography. In art. See also. References. External links, Forging Magazine, all issues available online free of charge. The ERCNSM, a metal forming research organization at The Ohio State University.